Good everyone, my name is Graphics. Looking at your screen, you see a diagram, and a diagram represents a circuit, and the circuit is made up of four elements. Two of the elements are passive, and the other two are what? Active. Just like I told you in my previous video, the active element are the element that provides energy into the circuit. And the two elements here that provide energy in form of current into the circuit is the 3-volt source, voltage source, and the 2 ampere current source. Remember, this current source is an independent current source. Start taking, and the direction of the arrow is telling us it's flowing in this direction. Now we have two passive elements here, which are the resistors. One of the resistor has a resistance of 6 ohms, and the other resistor has a resistance of 9 ohms. We assume that this 3 volts source provides a current. We'll call that current I1, right? And this 2 ampere current source, we'll call it I2, which we know the value here. Now the I1 and I2 will meet at this point here. Let's say point B. Point B is a node. And both of them will form I3, which will flow down across this 9 ohm resistor. So in a nutshell, we are told to look for I3. Depending on how you want to introduce your variables into this circuit, you can use your I0, you can use your IA, whatever you want to use, right? Now, we are told to use superposition to detect or to find the current that will be flowing through this 9 ohm resistor. We already denote that the current should be I3, but we don't know the value of what? Of I3. So one of the things you do first is to short circuit the 3 volts voltage source, or you open circuit the 2 ampere current source. Whenever it's a voltage source, you short circuit. Whenever it's a current source, you open circuit. You get the logic? So I'm short circuiting the 3-volt voltage source. Now when I short circuit, this is what I'll have, meaning that I'm removing the 3-volt source and I'm replacing it with a wire. So there's no element anymore, it is just a wire altogether. Now because of that reason, all the currents will start flowing in towards the left hand side, because it is only the 2 ampere current source that will be producing current into this circuit. Now I will be calling this will not be my I2, but now it will be my I2 prime, so that I will not confuse I2 from when I've short circuit the 3-volt source and when I have not short circuit the 3-volt source. So I'll call it I2 prime. Now the I2 prime will flow and get to this point B, which is the node, and it will split still to I1 prime and I3 prime. You will not change the position of the current that you've assigned already. You will not change the value, the variable. You still use the same I1 and I2. What you just be putting there will be what? Prime on it altogether. Now, like I've told you earlier in my previous video, that if your source is at the right hand side, you start taking your equivalent resistance from the left hand side. And if your source is at the left hand side, you start taking your equivalent resistance from the right hand side. This is what I mean. Since I have my 2 ampere resistance here, right? So what I'll do here is I'll start moving from this side. So you look at that. Since the split I3 prime is going through the 9 ohm and I1 prime is going through the 6 ohm, right? So because of that, they are now in what? In parallel. Because when two different currents are flowing through different resistors, you see those two resistors are in parallel, especially when they are coming from one source. Do you get the logic? Now in this circuit, the first thing you have to look for is your total current. And we already know my total current, which is I2 prime, and that is equal to what? 2 ampere. Note, the value is given already. Now, the equivalent resistance will now be equal to 6 parallel to 9, which I explained to you earlier, because two different currents are flowing through the resistors. So, this means you multiply 6 by 9 divided by the addition of 6 and 9. And 6 times 9 will give us 54, divided by 6 plus 9 is what? 15. Now when you divide 54 by 15, your arrow equivalent or your arrow total or your arrow combined will be equals to what? 3.6 ohms, right? So this is what we have here. Now we already know my value for I2 prime, which is 2A. Now we want to know what in the amount of the 2A that will flow through the 6 ohm, which is I1 prime. I want to know the amount of the 2A that will flow through the 9 ohm, which is I3 prime. So in this way, one of the ways we can achieve that is by using current divider rule. Now, remember I told you earlier, the best way for you to remember how to use a current divider rule, let's just go one side here. Remember that my arrow equivalent is giving us 6 times 9 over what? 6 plus 9. Is that taken? And I want to look for I1 prime. Now let me remove the arrow equivalent and I put my I1 prime. You see what I'm doing? Now the I1 prime is flowing through where? It is flowing through the 6 ohm. It means that I am going to remove the 6 ohm and I'll replace it with something. What would I replace it with? I'll replace it with what? The I total, which is what? Giving us my I2 prime. Is that taken now? And I'll multiply it by the 9 divided by the 6 plus 9. This is the only modification I'll take there. And what is my I2 prime? My I2 prime is 2A. Is that taken? So when I multiply 2 times 9 all over 6 plus 9, that will give us 18 over 15. And if we divide 18 by 15, your I1 prime will be equal to what? 1.2 ampere. So that is my I1 prime. Similarly, I'll do the same thing for my I3 prime. Let's do it again. I'll come here, my arrow equivalent is given as 6 times 9 all over 6 plus 9. Now if I remove my arrow equivalent and I place my I3 prime, this will now be equals to, you now look between 6 and 9, where is I3 prime flowing through? It is flowing through 9, right? So you are going to remove the 9 and you're going to replace it by what? By the total current, which is what? I2 prime. All together. So if you start putting your value now, your I3 prime will now give us 6 times 2, that is my I2 prime, all over 6 plus 9. And 6 times 2 will give us 12, all over 6 plus 9 will give us what? 15. So my I3 prime will now be equals to, if you divide 12 by 15, you'll be having 0.8 ampere. So my I3 prime is given as what? 0.8 ampere. So we are done with that. This is what the 2 ampere is doing to the circuit when the 3 volts is not present. How good now the current it is providing when the 3 volt is not present. Now, similarly, you will now go and open, you will now do this next step is for you to open circuit the 2 ampere current source. Is that taken? So when you do that, this is what you are going to be having. So I've replaced my 3 volts back, right? The only thing I'll remove is I'll remove the 2 ampere current source. So when you remove it, this is what you'll be having. When you open circuit, it means that you are removing the element totally. Is that again? Now, everything still remain in place, my I1 prime, what do you notice? Everything will now be flowing towards the right, because the only energy here now is the 3 volts. So the force will be going towards the what? The right. So I have my I1 prime prime, since it's the second element I'm moving, so I'm putting prime prime, I1 prime prime, I2 prime prime, I3 prime prime. You can see that? This is what we're having now. So what do you notice? Since here is open, current cannot flow through this path anymore. Current will be flowing where there's continuity. Altogether, here there's no longer continuity here. There's an open circuit here. So making I1 and I3 to be in what? In series. Is that again? It's like removing these 2 points here, right? So from here, arrow equivalent will now give us 6 plus 9 equals to what? 15 ohm, because they are in series, due to the fact that this 2A is open, that part is open. Now we've gotten the equivalent resistance. Now the next thing is you look for the current. Now in this case, you look for the current, since current is not known. Now remember, my V is equals to what? I arrow, that is Ohm's law. Now when you make I the the formula, I will now be equals to what? V over arrow, right? So the I here you're saying is our I total prime prime equals to V, right, all over what? Arrow equivalent. Now if you put in, know one thing, that my I total prime prime is equals to what? My I1 prime prime. Because if you look at the current flowing through here is I1, which is the total current there. So this will now be equals to the V here is the voltage, which is 3, all over what? The equivalent resistance, which is 15. So my I total prime prime is equals to my I1 prime prime is equals to, if you divide 3 by 15, we're having what? 0.2 ampere, right? So since they are in series, right? Since I1, since 6 ohm and 9 ohm are in series, meaning that the same current are flowing through this 6 ohm and the 9 ohm resistor, making the I total prime prime to be equals to the I1 prime prime to be equals to the I3 prime prime, all equals to what? 0.2 ampere. Hope you understand that. Now we've gotten I1 and I3. Then what is I2 prime prime? I2 prime prime is 0, because no current is flowing through this part here. There's no continuity there. So you understand that? Now from here, we are now told to look for the I3. What do you notice? The I3 prime here and the I3 prime prime here are flowing the same direction. They're going down, down. So my I3 now will now be equals to what? I3 prime plus I3 prime prime. So my I3 will now give us 0.8 plus 0.2. So my I3 is equals to what? 1 ampere. And this makes sense. So the current flowing through the 9 ohm resistor, which is I3, is equals to what? 1 ampere. Altogether, and most times they might tell you to look for the voltage drop. Simple. The voltage drop here will not be equals to what? The voltage drop across the 9 ohm resistor will not be equals to what? The current flowing through the 9 ohm resistor, which is 1, multiplied by what? The resistance itself, which is 9. And that was to give us 9 volts. That is the voltage drop. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.